I want to start with a small puzzle, and I want you to sit inside it with me. Picture two pairs of players. Each pair is repeating the same simple game, the kind where on every round you either cooperate or you defect, and so does the other player. What's the first pair? They play cooperate, then a round where the first player defects while the second still cooperates, then cooperate again. Now the second pair plays the very same three outcomes, but in a different order. The defection comes first this time, then two clean rounds of mutual cooperation. So we have two routes through the same set of moves, same ingredients, shuffled. Here's what I want you to notice. If you only look at where each pair has ended up, they're in an identical position. Their current move is the same. Both have two rounds of mutual cooperation and one round where the first player defected, so their counts are the same. And in a fixed payoff table, the same counts by the same cumulative score, so the running tallies match too. If all you carry is the language the one-shot game hands you, current move, count, score, then you would have to call these two situations the same state. By that vocabulary, they are indistinguishable. But in the finite model behind this video, the probability of what happens next is not the same for these two. The futures fan out differently. Something that the summary threw away, the order the moves arrived, has quietly become predictive. So I want you to put the question plainly, and we will spend the rest of the video earning the answer. The game's own bookkeeping says these two are one state. The future says they are two. What did the game forget? And has repeated play quietly created a new object, one the game cannot name with its own words? Before we chase that object, let me be honest with you about the room we are standing in, because the boundaries of this room matter. This is a finite, repeated game laboratory. It is an operational model. It is not a reduction of real institutions to payoff tables, and it is not a theorem about every repeated game that could ever be played. Hold that line in your mind. Everything we find lives inside it. Now, what is actually in the laboratory? Let me show you the pieces. The games are two-player, two-action games, including a prisoner's dilemma and a stag hunt. Two players, two choices each, a fixed payoff table. And each player follows a simple kind of rule. A rule says two things: what you open with and how you respond to each of the four things that could have just happened between the two of you. An opening move plus four responses. Count the ways you can fill that in, and you get the complete catalog on screen, every deterministic memory one rule there is. A few of them you will recognize. They always cooperate, they always defect, the tit for tat, but they are just members of the full set. Nothing special is assumed. Pair a rule for the first player with a rule for the second, and you get the grid on screen. Every ordered pairing of those rules. The model lays a declared even prior across all of them, and then this part is the key. Recompute the resulting histories exactly. Nothing is sampled or estimated, it is all worked out. Now, here's the choice that does all the work. Once the play has happened, what is the lower layer actually allowed to look at? Think of it as choosing a lens. The simplest lens keeps only the current joint move. A richer lens also keeps how many times its kind of round has happened, the counts. And the richest lens adds the cumulative payoffs on top, although at a fixed game and round, those payoffs are already pinned down by the counts, so the last lens does not really add anything new. These are all perfectly legitimate descriptions though. This is the vocabulary the stage game itself supplies. And here's what every one of those lenses quietly does. Look back at our two opening histories through the richest lens we have. They come out identical. The lens does not catch them disagreeing about anything visible. What it discards is not a disagreement. It is the order. So, if the stage lens is throwing away something that matters, the natural impulse is to just keep everything, remember the whole past. But that is not what we want, and I think if you sit with it, you will agree. Let me lead you down a better idea. We have all of history available to us. Take every history the carrier can actually produce. That is the raw material. Now, the lazy move is to keep all of it, on the theory that more memory must be more powerful. But more memory is also mostly clutter. Here's the principle I want you to hold onto. Keep a distinction from the past only when it actually changes what comes next. If two different pasts lead to exactly the same future, stop carrying the difference between them. Fold them together. Only split two pasts apart when that split changes your prediction. That is the whole instinct, and the construction in this paper is just that instinct made exact. So here's the rule the paper uses to build what it calls the predictive state of play. Put two histories in the same state only when two things are both true. They look the same through the current stage lens, and they imply the same exact law for the declared future observations. Same now and same future. And that gives you the coarsest summary of history that is still enough to get the future right. Coarsest is the keyword. Think of it like a set of filling drawers. Two histories share a drawer whenever they share a future, and the moment their future diverges, they go into different drawers. We're not hoarding the past, we're keeping the smallest set of distinctions that still nails the prediction. In computational mechanics, an object built this way is related to what is called a causal state. Here it is installed as an operational model of an institution, a package of historical distinctions that has become predictive in its own right. Now, what's where our two opening histories land? The order of their moves changed which entries of the player's hidden rules got revealed along the way. Different rules revealed means a different best guess about which rule pair we're facing. And a different best guess about the rules means a different law for the very next public move. So the two histories fall into different drawers. I will call them MA and MB. And they are not the same drawer. The state summary cannot tell them apart. The predictive state has to. Now, a skeptic should be staring in you right now, and good, because the next question is the one that actually matters. We have given this thing a serious name, the predictive state, the institution. But maybe it is just a stage description wearing a costume. So let me ask it sharply. Could you compute this institutional state from the stage game summary alone? If I handed you only the current move, the counts, and the score, could you always reconstruct which drawer we are in? If the answer were yes, then there would have to be some function leading from the state summary up to the predictive state. And that function would force a particular consequence. Any two histories the stage lens calls identical would be required to land in the same drawer. Same below would have to mean same above. And this is exactly where our split pair refuses to cooperate. Look at them again. A corporate, defect corporate, and defect well, blah, blah, blah. Through the richest stage lens, every field matches. They are the same below. And yet, the exact finite recomputation places them in different predictive states because their future laws differ. Different above. So that promised function cannot exist. There is no way to read off the predictive state from the stage vocabulary on this carrier, because here are two cases the stage vocabulary cannot tell apart that the prediction insists are different. You can see the failure in the diagram. One stage class is trying to point at two different drawers at once, and a single function is not allowed to do that. The bridge snaps. And that is the strict extension certificate in its most intuitive form. The higher description draws a distinction the lower description simply cannot express. Notice what the test is and what it is not. The test is not that the upper layer is more complicated. It is not that it has more variables sitting around. The test is non-factorization. The new distinction cannot be routed through to the old package, no matter how cleverly you try. Non-factorization tells us that something is missing. The next honest question is, how much? Can we put a price on what the game forgot? The paper calls this price the closure deficit. In symbols, it asks, once you already know the current state's description, how much does the full process state still tell you about the future on top of that? The size of that gap is the figure the meter on screen is tracking. In plain language, once I know the current move, the counts, and the score, how much better could I predict the future if I also knew the history distinctions the state's length erased? That improvement, that buyback, is what the deficit measures. And it is missing predictive information. It is not an energy cost, and it is not a welfare loss. It is just prediction left out on the table. There is a clean reason the price is well defined here. On this finite carrier, once you fix the ordered rule pair in the public history, the future play is completely determined under the declared continuations. There's no leftover coin flip baked into the world, so any uncertainty you still feel when you look through the stage lens is not noise from the universe. It is entirely the fog created by the distinctions the lens threw away. That's clean. And the paper splits that missing information into two honest pieces. The first piece is what you buy back by conditioning on the institutional state, the predictive improvement the institution actually recovers. The second piece is what stays uncertain even after you know the predictive state, because you can still be unsure which underlying rule pair you're facing. So the institution is not magic foresight. It is the minimal package that restores the correct future law. Notice what I'm not saying. I'm not saying it makes every outcome certain. It can close the description, give it a complete and self-consistent update, while the outcomes themselves still branch. Closed and certain are two different things. There's one more subtlety here, and it is a lovely one, so let me slow down for it. Finding a partition that predicts well is not the same as having a finished object with a law of its own. Let me draw that distinction out. Early in the finite repeated game, the paper finds what it calls a formation regime. Here is the tension. Any summary rich enough to keep all the future distinctions you need still has to reach outside itself to update. It leans on details that are not contained in any self-contained rule. And if instead you coarsen it down until it can update on its own, autonomously, you have thrown away distinctions the prediction needed. Future sufficient or autonomous. Early on, you cannot have both in the same package. But keep the interaction running. The predictive distinction gets refined again and again until refining one more time changes nothing. The partition saturates. It reaches a fixed point. And once it has saturated, the canonical institutional state crosses into a formed regime. Now it is both things at once. On the declared institutional lens rows, it's future sufficient and autonomous. Knowing the current institutional state is now enough to state its own macro update law. So emergence here has a shape in time. First, history carves out a useful distinction. Then, repeated interaction stabilizes that distinction into a state that can carry its own update. The paper is careful right here, so let me be careful too. It does not say that every institution becomes closed the moment we decide to call it one. Naming is not forming. What it says is that this exact finite construction contains earlier rows where the package is still forming, and later rows where it has become a state law. The promotion has to be earned, not announced. Now everything so far lives inside the lab. A finite carrier can prove what is possible inside its own construction. What it cannot do all by itself is tell you that real people out in the world organize their behavior the same way. So the honest move is to go and look. And the paper does that. It pre-registers a reanalysis of an already published, infinitely repeated prisoner's dilemma experiment before anyone touched the data. The hypothesis, the model comparisons, the held-out splits, the seeds, the pass-fail thresholds, all of it was frozen in advance. You commit, then you test. You do not get to move the target after you have seen where the arrow landed. The first test sets up a small race on data the models have never seen. One predictor is allowed only the current stage profile. The other gets a short window of recent history as well. And to be clear about what this is, that history window model is a stand-in, a data-side proxy. It is not the canonical institutional state living inside a person's head. And the history model wins. On held-out decisions, it predicts better. But the amount you can see on screen, it is a small gain, but a consistent one. And its whole interval sits above the minimum effect the authors committed to in advance, so the residue test passes. And this is not a thin result resting on a handful of moves. The number of sessions and the number of decisions behind it are on screen, and there are a lot of them. So, what did we just learn? Something modest and worth saying clearly. In this dataset, the current game state leaves recoverable predictive residue sitting in recent history. The same question the laboratory asked turns out to have a real answer in people too. But notice the barrier on the screen. This is a shared question, not a bridge theorem. The data do not prove the finite model is what is running inside this place. And then the data did something even more interesting. It corrected me. The pre-registered story predicted that history would matter more early in the relationship and fade as people settled in. Early should beat late. The opposite happened. As you can see on screen, the late gain was the bigger one. And the early minus late difference sits entirely below zero. The prediction did not just come up short. It reversed. So the central residue test passed, and the proposed timing mechanism failed, in reverse. And the paper keeps both. It does not quietly average the negative way. If anything, the reversal hints at a different story. That history-dependent conventions might crystallize with experience rather than fade from some initially reached starting state. The human data do not certify the theorem. They sharpen the question. Let me put 3 reasonable objections to myself, because if you're still skeptical, you're probably forming one of them. The first objection: this is just memory, not an institution, and that is fair. But memory is the raw material, not the finished object. The thing defined here is narrower than memory. The coarsest saturated state that preserves the declared future law and survives the non-factorization test. Calling that an institution is an operational modeling choice. It is not a claim that every institution in the world is fully captured by a predictive quotient. Second objection: of course, changing history changes the future in a repeated game. That is obvious. But that is not the claim. The claim is sharper. The claim is that 2 histories, the histories that the richest stage vocabulary has already declared identical, these histories still demand different predictive states, and that the model computes the minimal repair that fixes the failure. Third objection: a catalog of memory 1 rules cannot establish a theory of real institutions. Correct. It does not try to. It establishes one exact worked example on a finite carrier, and the human data result adds one pre-registered predictive comparison in one published dataset. Look at the fence on screen for what stays outside it. None of this licenses a universal sociology, a welfare theorem, an equilibrium selection law, or a reduction of society to games. And certainly not to physics. So, back to where we started. Can a game give birth to an institution? Inside this declared finite laboratory, the answer is yes. And the witness is concrete. Here are 2 histories one last time. Same current move, same count, same cumulative payoffs, and the different exact future law. The game's own words say one state. The future says two. Repeated play built an object the state's game cannot name. And notice why we accepted that object. Not because it sounds social, not because it looks complicated. It earned a scoped certificate every panel on the screen. It is the coarsest future sufficient summary. It does not factor through the stage description. The information lost below can be priced, and the state can enter a formed autonomous regime. The human data analysis adds a real constraint on top of the construction. Recent history improves held-out prediction beyond the current profile in one published dataset. And at the same time, the pre-registered timing bridge fails and points towards a different acquisition story. We keep both. Show the object, show the test, show the controls, and keep the failed prediction. And here's the one line of scope said once and said plainly. This is an operational model of institutional extension. It is not a claim that cities are literally games, that society reduces to physics, or that the same material mechanism makes a proton and a norm. What it is a way to engineer emergence and then check your work. Build the higher object, then prove it, and prove it is more than a new name. And that last move is the part that travels. Not the games, not the rules, not the physics. Those stay in their own domains. What carries across is the audit question itself. And it is the same question every time. What did the lower description forget? What new package repairs the prediction? And can we prove the repair is more than a new name?